Chemical reactions. Today's lesson, you need to understand how we write chemical equations, know what it stands for, and know what all the necessary components are in a chemical equation. You also need to understand the symbols, and at the end, you need to understand how to write an unbalanced equation by putting the reactants and the products on the correct side of the equation. Chemical equations are used to describe the substances that react, called the reactants, the substances that are formed, which are called the products, and finally, how much of each substance are involved in the reaction. A chemical equation is basically a shorthand notation used to describe a chemical reaction. Just like a chemical formula is used to denote how many of each atom are in a compound, a chemical equation are used to express the quantitative relationships between all compounds involved in the reaction. For example, if we take a reaction between magnesium and oxygen, it reacts to form a compound that we know called magnesium oxide. Now, taking a look here, you'll notice a couple things. The little 2's in front. So what does this mean? This means two atoms of magnesium react with one molecule of oxygen to produce two molecules of magnesium oxide. Later on, you're going to understand what those 2's mean and how to put them there. Right now, it's not that important. So let's talk about writing an unbalanced equation. The first thing you need to understand is you need to understand the compounds involved in the reaction, and therefore you need to specify them. The reactants, or the ones that are used to react in the chemical reaction, go on the left-hand side of the arrow. The products, or what is formed during the chemical reaction, go on the right-hand side of the arrow. The arrow represents the direction of which the reaction takes place. Sometimes an arrow can be in both directions, meaning that the reaction could go either forwards or backwards. But right now, we're only going to be concerned with reactions that move in one direction, from left to right. Since we are dealing with an unbalanced chemical equation, you do not need to add big numbers or coefficients in front of the chemical compounds. Later on, we will put those numbers there, and you'll learn how to do that in the next lesson. Another thing you need to understand is you need to understand the physical states of the reactants and products by using the following symbols. S stands for solid, L stands for liquid, G stands for gas, and finally, anything that's dissolved in water is considered to be aqueous. Here's some more symbols. Notice the little plus sign refers to more than one reactant or product being used. The little arrow means yield or produced. These down here we're not going to use very much, but this one in particular I want you to be aware of, and the little triangle means that the reaction is undergoing some type of heating process. So therefore, let's review. Reactants are substances that are consumed, and they are on the left side of the equation. Products are substances formed, and they're always on the right side of the equation. Here are two examples of equations that you might see. Remember, reactants go on the left, products go on the right. So, our example before, we have magnesium and oxygen, these are our reactants, and magnesium oxide is the product. Notice the little symbols right here, and these refer to the states of matter. S stands for solid, G stands for gas. Here's another example. Copper and oxygen make copper oxide. and this would refer to copper 4 oxide. So remember the little symbols. S stands for solid, G stands for gas, L stands for liquid, AQ stands for aqueous, and these are going to become important. Again, the reactants are on the left, products are on the right. Some other more useful information on writing equations, something that you might have forgotten about, is the 7 diatomic elements that are gases that always are in molecular form. Okay, in other words, they always have 2 atoms bound together in a covalent compound. So here they are. You need to remember them when writing your unbalanced equations. So let's take a couple of examples here, and so you can get some practice. Practice problem number 1. When doing these problems, it's always good to label what you have. So let's take a look here. Methane gas was burned using oxygen gas. This reaction produced water vapor and carbon dioxide. The best thing to do here is to label each thing when putting together an equation. So for instance, methane gas, it's going to be either a reactant or product. And since it's going in, it's going to be a reactant. It's burned using oxygen, so that is another reactant. This reaction produced, okay, so this is where the arrow goes, water vapor, this is a product, and carbon dioxide, another product. So you take this information and you put it down in an equation, and it looks like this. Now, next thing that I want to ask you is, based on this equation, what is the reactants and what are the products? So, the reactants were methane and oxygen. The products were water and carbon dioxide. Let's take a look at another example. Okay? If we take pure hydrogen gas, H2, okay, pure refers to one of the diatomics, is ignited with oxygen gas, another diatomic, okay, and this is going to be a reactant, this is going to be another reactant, will form, okay, this is where the arrow goes, water vapor, H2O, and this is a product. Okay, so now you need to write an unbalanced equation using this, and you cannot forget the states of matter. So it looks something like this. Okay, notice the little G's stands for the states of matter. Now, let's take a look here, see if you can recall. What were the reactants in this problem? If you said hydrogen gas and oxygen, you were correct. What were the products? Water. And what were the states of matter of the reactants? Well, they were both gases. And what about the state of matter of the product, which was water vapor? If you said gas, that was correct. Take a look at your homework set and use these notes to guide you through those problems.